because I know, but 10 minutes is a good way to introduce the concept. And, if you have 10 minutes, you should probably use that 10 minutes. It's generally a good thing to do. I promise I won't use all of them. Um, so, two-dimensional motion. What's the difference between one-dimensional motion and two-dimensional motion? Not quite. Not quite 3D, but it's more like 2D. We've done one-dimensional motion, and that's motion in a straight line. But the main thing that we're going to be dealing with in two-dimensional motion is we're going to be doing ballistics problems. So, do y'all know what ballistics is? Yeah, what's a ballistic missile do? It does. Okay, and that curve is what we're actually going to be concerned about. Because, like, if you take a ball and you throw it in the air, it doesn't go like straight up and down, and it doesn't do this. It's not like if you threw a ball and it did this, that's going to be very confusing, right? That's not the natural path that we see whenever we throw something. Unless you have, in which you need to let me know, and we need to have a talk about where you've seen such a thing. What does it do instead? It curves, but what kind of curve does it make? It is a very you're right. It is a very specific exponential because it kind of makes this curve that goes like this. You get, yep, it makes a parabolic trajectory. The path that a two-dimensional object goes as it goes through the path is called the trajectory, and that's just a fancy word for its displacement in two dimensions, or the path that it takes. So if it starts off over here and goes all the way through here, this individual path is its trajectory. Okay? And the reason why this is so important to us is that, well, every time you're throwing something outside, it's under the influence of gravity. So this is a really common uh, physical phenomenon that we see all the time. So it's important to try to digest it and figure out what's actually happening here. And whenever we do analyze it, we figure out a couple of things. One, is there any acceleration that occurs in the left and right direction? I'll go left and right, and then I'll make this the y direction, I'll make it up and down. Think about that. Okay, but the acceleration is, if it's got to go up somehow, that acceleration comes from the Earth, not the left and right direction. So if we think about the acceleration that's happening on an object, it is always in its trajectory going to be the exact same thing every single time we analyze it. Gravity is going to be pulling it down at 9.8 meters per second squared. So instead of writing 9.8 50 million times, I'm just going to draw these arrows and I'm going to put G. So we have G, 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 all the way down. Okay, and that is the only time that we have acceleration happening in this trajectory. From left and right, there is no acceleration. Think about it. The moment that it leaves contact with your hand, you no longer have any control over that ball. And if you have no control over that ball, that means you cannot accelerate it nor accelerate it in the negative direction. I almost said decelerate. You can't really accelerate it either direction. So once it leaves, there's no control over that. And since there is no control over that, we have to assume that there is no x acceleration. Okay, but there's a y acceleration. So what is, yeah, go ahead. Okay, okay. Absolutely. Yeah, so like the case was brought up, if you take a object and you like say it's tied to a rocket and you accelerate it, it would have acceleration in the x direction in that case, but it would also no longer make a parabola. So, because it would be speeding up, so your parabola would be stretched out, so it wouldn't look quite like a parabola. It would look like a curvy boy. If you had a rocket attached to your ball, it would look more like this, and then it would kind of smooth. Sorry, it would still kind of hit the ground right here. But instead of it looking like crap. Instead of looking like a parabola, it would kind of like stretch out over on this side because it's still speeding up in the x direction. So it wouldn't be a true parabola if you did it that way. Is it possible to do? Yeah. Is that outside of the realm of AP physics? Yeah. We're not going to worry about that too much. Okay, because really the whole point of the AP Physics part, just doing a simple trajectory throwing a ball problem, is that there are two directions that we have to worry about. We have to worry about the x direction, and it's going to have its own dvat, and then we're going to have to worry about the y direction, and it's going to have its own dvat. So whenever we set up problems like this, we have to include the x direction and we have to include the y direction, and we have to solve both of the problems equally at the same time. The deal is in the x direction, acceleration is equal to 0 meters per second squared most of the time, unless you're attaching rockets to the objects. And in the y direction, acceleration is going to equal negative 9.8 meters per second squared. So these things are like always true, always true. Okay. And that's one of the hardest things that people have to get through their minds is like if you're looking in the up and down direction, that's going to be negative 9.8 meters per second squared. If you're looking in the left and right direction, that acceleration is always going to be 0. In fact, it's always going to be a constant speed. So that means usually whenever we're dealing with these problems, you can just use velocity is equal to distance over time for the x stuff. For the y stuff, guess what you get to do? Kinematic equations. I can't spell kinematic. There we go. Equations. And there are 4 of those. 3 of them are on the formula sheet. One of them is a forbidden equation. You're welcome to use any one of them. There are also a couple of formulas that we can use as well that we can memorize, but they're not on the formula sheet. And we'll try to go through those as well too. But I don't really have enough time to do that right now. And I told you guys I wouldn't use all the 10 minutes. So I think for right now, this is what we're going to try to jump into tomorrow. And it's going to be interesting for sure. So I think that's it. That's it for right now.